In this video, we are going to discuss a very important topic which is often asked in Java interview, and that is what is the difference between equals operator and equals method. So in this video, we'll discuss this and try to understand the difference between two. So let's get started. So first of all, equals operator, which is denoted by double equal symbol. So it checks reference equality. What it means is that it checks whether two variables point to the same object present in the memory or not. While the equals method, which belongs to the object class, it checks and compares the actual contents of two objects. So what do I mean by this two statement? So to understand it properly, we'll take a look at an example. So let me go to my STS. So here I have two strings. I have created two strings using string literals. One is S1 and S2, and I have assigned the hello string to both of them. So if you know about string pool concept, uh, then you might be knowing that if I create two string using string literal and I assign the same value to both of them, then only one object will be created in the string pool. If you don't know about string pool, you can check out my previous video where I have explained string immutability. So you can check that video to understand the string pool. Now, as I have defined two strings with the same value, same string, hello. So in the string pool, let me go to the diagram. So in the string pool, so here we have the heap memory. In the heap memory, all the objects are created, and inside heap memory there is a special area called string pool. So inside the string pool, an object will be created with the value hello. Okay, and the reference variable, those are stored in the stack memory. So my reference variable s1 and s2 will be stored in the stack memory, and they will point to the same object hello. Okay, this is done for memory optimization. So s1 and s2 will point to hello. So now we'll check the reference equality and also the equals method. So now if I check the reference equality, right? So let me print the reference equality of these two string. So I'll do system dot out dot println. So for reference equality, I'll do s1 equals s2. So here I am checking the reference equality. So reference equality means whether both the reference variable are pointing to the same object. Yes, they are pointing to the same object, as we saw in the diagram, right? They are pointing to the same object. So in this case, this should return true for me. So let me run the code. So yeah, as expected, it has returned true. Now I'll check the equals method. Yes, so equals check whether both the objects have the same content or the same value. So are they having the same value? Yes, they are having the same value. That is the string hello, right? So it should also print true for me. So yeah, it has printed true. Now, okay, now let me modify one of the string. I'll modify the string uh, s2. So I'll change it to hello world. So now whether both the strings have I mean both the strings have the same content. No, they are not having the same content. One is having hello, another one is having hello world. So now it will return false. The equals method will return false. So if I run the program, yeah, it has returned false. And whether the reference are same, I mean the reference equality holds true for this s1 and s2. So once I modified this string, right, this s2 string, once I modified the s2 string, what happened now, there will be another object, right? Because string is immutable, so it cannot be modified once the value is uh, once the object is created for the string, right? Its value cannot be modified. So what will happen, and another object will be created if we modify the string. So this will be hello world. So another object will be created with the value hello world. So now what will happen, uh, so s1 will point to hello object, s1 will point to hello object, and s2 will point to hello world. So now, does s1 and s2 refer to the same object? No, they are referring to the different object, right? They're referring to different memory address. So this should return false for me, right? So if I run the program, yeah, so it has returned false. So I hope you have understood the difference between equals operator and the equals method. So let's take a look at an example where we create the string with the new keyword. So let me comment out this string s1 is equal to new string hello, and I'll create another string s2 with the same value, same string value. Now tell me whether it will print true or false, whether the reference equality are same or not. So the thing is, whenever we create any string object with new keyword, right? If we create any object with new keyword, then that object is created inside the heap memory but outside the string pool. So now what will happen? Object will be created outside the string pool inside the heap memory. So let me copy, 1 second. So let me copy this. So this is one object, and we have created another object, right, s2. So there will be another object with the value hello. Okay, so now, and s1 or s2 are reference variable, they will hold the reference for these two objects. So s1 will point to one of the hello object, and s2 will point to one of the hello object. So now, whether the reference equality is same? No, it is not same. They are pointing to different objects, right? S1 and S2 are pointing to different object present in the heap memory. So this will return false. This will return false. Okay. So if I run the program, so yeah, it has returned false. Now let me check the equals method. So whether the equals method checks the uh, contents of the objects, right? So whether the contents are same, yes, they are same. S1 is having the value hello, S2 is having the value hello, right? So it will return true. So if I run the code, so yeah, it has returned true. So I hope with this example, it has made the concept much more clearer. So now, what is the best practice? Like when to decide when we need to use the equals operator, or when we need to use the equals method. Uh, so, like if we need to compare the actual values of two objects, right? When we should use the equals operator, and when should we use the equals method. So uh, to decide that, the best practice is that use equals operator for reference comparison or primitive types. So if we need to check the uh, value, the actual value stored for primitive data types, then we can use reference operator. And if we are doing reference comparison, then we can use the reference operator, reference equality operator. And if we need to check the content or the value comparison of object, then in that case we can use equals method. So this is the best practice, this is the rule of thumb. Why for primitive types we need to use reference equality operator for comparing the values, actual values? The reason is that primitives data types, uh, they store values, not the references. So what I mean by that is that, uh, let's say if I say int a is equal to 10, right? So int is a primitive data type. So this will not hold the reference of the object of this 10 value object, right? It will hold the value itself, the 10 itself, in the over here. So a will contain 10 only. So primitive data types, they store the actual values, not the references. But when we create any object, right, any object, they hold the reference of an object. So this is one object. So s1 will hold the reference, the memory address of this object. So primitive data types store values, not references. So when comparing the actual values for primitive data types, we can use the equals operator, right? We can use the equals operator for that. Uh, now okay, now so whenever we are defining int a is equal to 10, right? So I wanted to give one more information so that it is much more clear to you. So this will be stored in the stack memory. We know that reference variables are stored in the stack memory, right? So uh, this a will hold the value 10. So both uh, this variable, right, a and the value will be stored in the stack memory. It is not like that a will be stored in the stack memory and 10 will be stored in the heap memory, not like that. So uh, a and 10 will be stored in the stack memory. So now, okay, so now we'll look at an interesting example using wrapper class. So let me type this integer. So you know about wrapper class, right? Wrapper class are the classes that converts a primitive data type into an object. So for int, the wrapper class is integer. So integer a is equal to, let's say, 120. Okay. So I created a one object a with the value 120 and integer b also 120. Yeah. So now let me delete this a reference equality operator and then b. So let me comment it out. This one. Now what it should return? So let's check this, like what it will return. Okay, it has returned true for me. But these are two different objects, right? A is another, uh, is one object and b is another object. So these are two different objects, but it should have been like this, right? In the heap memory it should have been like 120, and B will point to 120, and A will also point to 120, but both are different objects. So it should have been like this, right? But here and they're pointing to different objects over here, but here it is returning true, right? So it should have been false because they are pointing to different objects, right? So let us change the number. Let's say I give 127, and then again run the code. Okay, it is returning true. Okay, fine. But as per the logic of object creation in the heavy memory, it should have been false, right? So let me change it to 128. Okay, but now if you see, it is returning false, but the value are same, but earlier it was returning true. So why is that? Why for some numbers it was returning true, uh, but now it is returning false, which is correct as per our intuition, that the knowledge we have regarding objects, right? So the thing is, uh, I'll go back to the slide. So here, if you see, this is called integer caching. So the thing is, in Java, the wrapper classes like integer, byte, short, character, and long cache small values to save memory and improve performance. For integer, the default cache is from negative, so it is negative 128 to 127. This means that when you create integer objects in this range, Java reuses the same object from the cache. So the thing is, now it is 128, right? So this is outside the range of negative 128 to 127. So what will happen in the heap memory? In the heap memory, there will be two objects called 128, one with value 128 and another value with 128. So now A or B are pointing to different objects. So this reference equality, it will return false because these are not same, right? So it will return false. But as soon I change the number to a number that is inside the range between negative 128 to 127, let's say I give 127. So now what will happen? Java will cache this number. So it will have like an integer cache where it will store the value 127. So let me copy this. Okay, let me just integer. This is the integer cache. So Java will store this 127. This is 127. This is within the range, right? So to save memory, it will store this in a cache inside the heap memory, and both A and B will point to the same object, to the same cache object. So now they are pointing to the same object, right? So for this, it will return true. Yeah, so this process is called integer caching. So for the numbers between the range of negative 128 to 127, uh, the integers will be cached in this integer cache inside the heap memory. And if we reuse the same number, I mean, that number will be cached, and the variables will point to the same object. And this holds true for the wrapper class. So this is one additional information I wanted to give. So yeah, I hope you have understood the difference between equals operator and the equals method. So if you have got something from this video, so don't forget to subscribe and hit the like button.